Welcome to this instructional video on using this program, simulating the reaction between calcium carbonate and hydrochloric acid. When you open the simulation, using the link on the worksheet, you'll notice a diagram on the left with gray particles arranged as a solid representing calcium carbonate chips at the center and red dots representing hydrochloric acid particles moving randomly in the aqueous solution. In this experiment, you can adjust three variables: the number of pieces of calcium carbonate, the concentration of hydrochloric acid, and the temperature of the solution. To start your experiment, first select one of these factors as your independent variable. For this demonstration, I'll investigate the effect of temperature on the reaction rate. Consequently, I will keep the number of calcium carbonate pieces and the concentration of hydrochloric acid set at the same values for the whole experiment. They are my control variables. With these control variables fixed, I'll set my first temperature value at 0 degrees centigrade. To begin the trial, click Start Experiment. You will observe acid particles moving and colliding with the calcium carbonate, producing small blue dots representing carbon dioxide gas. The graph on the right displays the volume of carbon dioxide collected in the gas syringe over time. To conduct a preliminary trial and check for a noticeable impact, I'll raise the temperature to 100 degrees and click New Trial, which resets the simulation. Clicking Start Experiment again, observe how increased temperature raises the kinetic energy, causing the acid particles to move faster and collide with greater energy, significantly speeding up the reaction rate, as evident in the graph. For the formal experiment, reset the simulation to your initial values. In this example, back to 0 degrees. Repeat the experiment 5 times with the same settings by pressing New Trial and then Start Experiment each time. This repetition allows you to calculate a reliable mean rate and determine the standard deviation. After completing 5 trials, click Export to CSV to download your data. Import this CSV file into spreadsheet software such as Google Sheets or Excel. From there, copy your data into a pre-prepared table in Vernier Graphical Analysis, a free tool linked in your method sheet. In Graphical Analysis, select all 5 trial datasets to plot them together. You will notice that the lines appear to begin as straight lines, then start to bend away as the rate of the reaction slows down. It is therefore best to compare the first linear section of the graphs, referred to as the initial rate of the reaction. Highlight the first 50 seconds of each graph, click Apply Curve Fit, ensure Linear Fit is selected, and press Apply. You can now record the M value, the gradient of each line, into your processed data table. Finally, calculate the mean initial reaction rate and the standard deviation using your spreadsheet's functions. You will need to repeat this exercise for 4 more values of your independent variable in order to complete your processed data table and be able to analyze the effect that your chosen independent variable has on the rate of the reaction. Thank you for watching. Good luck with your experiment.